Hi students, now we are going to explain Huygens principle. Now this Huygens principle is actually based on a geometrical construction, very easy to understand. So for that I am going to consider an example of a spherical wavefront. So I have taken O is a point source which is at a finite distance, nearby distance. So we have already studied a point source at a finite distance emits a spherical wavefront. So you can see a sphere, okay, which is drawn around the center O. Now this sphere is going to expand because the light emitted by the source at O is going to travel at a speed of 3 into 10 power 8 meter per second. That is the speed of light in free space or air. So with that speed 3 into 10 power 8 meters per second, this sphere is going to travel forward. This is imagined in a slightly different way by Hygen. So for that, at a time t equal to 0, let us take at a time t equal to 0, that is at the initial time. This portion of the sphere I have considered. The portion of the sphere which I am going to consider is AB. So AB is a portion of the spherical wavefront. It is going to travel forward in all the directions. Okay, with respect to this AB, on the right side I am going to consider how it is going to travel forward. With what speed it is going to travel, I told you is 3 into 10 power 8 meter per second. So after a time t, the wavefront AB will not be at the same position. It will be forward. Somewhere it will be in the forward direction. Okay. Now, how to find where it will be? How to find where this wavefront will be after a time t? Okay. It is now explained by Hygen in a different way. So, for that, now what Hygen explains is every wavefront, whether it is a plane wavefront or cylindrical or circular or spherical, every wavefront is considered to be made up of several points. Say for example, I will take a point here. Okay, this is one point on this wavefront and this is another point and here. I have considered 3 points located on the given wavefront AB at a time t equal to 0. Now, Hygen says that each point, say for example P, Q, R, like this, each point on the given wavefront AB will also act as a point sources similar to that of O. Because O is a point source at a finite distance, it emits spherical wavefront. Suppose if you imagine P, Q, R, which are some other points on the given wavefront, they also will act like point sources. This was explained by Hygen. Okay, if P, Q, R, they behave like point sources at finite distance, they should also emit spherical wavefront or not? Yes or no? But their shape will be smaller. So, here with P as a center, small spheres will be emitted. These smaller portions, smaller spheres are called as secondary wavelet. They are not a wave front, they are wavelet. Where are they coming from? They are all coming from the given wavefront. The given wavefront is AB, which is spherical. P, Q and R are the 3 points on the given wavefront AB. They behave like sources now. So these points P, Q and R are behaving like sources and they are emitting small spherical waves. They are called as wavelets. And I give the name as secondary. They are called as secondary wavelets. So these smaller spheres emitted by the points P, Q and R located on the given wavefront AB, they are called by the name secondary wavelet. So wavelet is a small wavefront only. Okay students, now I am going to join. See here, the light is traveling in the forward direction like this. The light is traveling in this direction. So from every point you can see that the direction of propagation of light is perpendicular to the surface, perpendicular to the surface of the wavefront. Okay, now if you join the locus of all the points which are at equidistant from the given wavefront, I am going to join all these points. So this A dash B dash, A dash B dash is the locus of all the points, okay, or it is the envelope of all the points having the same state of vibration, and it is also the common tangent drawn to these secondary wavelets. The common tangent drawn to all these secondary wavelets. So this envelope A dash B dash accommodates all the secondary wavelets. This A dash B dash accommodates what the smaller secondary wavelets emitted by P, Q and R. So this A dash B dash is getting a new name that is called as the secondary wavefront. That is a new wavefront. So this A dash B dash is called as the secondary wavefront. How is it formed? How is the secondary wavefront formed? As an envelope of all the secondary wavelets. So secondary wavefront is an envelope. It is an envelope of all the secondary wavelets. So this only is called as a Huygens principle. So after a time t, you can see that after a time t, the new wavefront, which is an envelope of all the secondary wavelets, will be at some other location. So where it will be also can be found by using the Huygens principle, that we are going to explain after this. Before that, according to Huygens principle, every point like P, Q, R, which are lying on a given wavefront, these points act as sources of light. So they emit small wavelets, okay, they are called as secondary wavelets. And you see these A dash B dash is an envelope, okay, it is an envelope which is on the forward direction, which is in the forward direction. So the forward envelope of all the secondary wavelets gives a new wavefront. That new wavefront is also called as a secondary wavefront. Okay students, now what is the use of Eigens principle? Means we can locate the position of the new wavefront after a time t. Okay, after a time t, where will be the secondary wavefront can be located by using the Huygens principle. So for that I have considered first a spherical wavefront. Now the same I am going to explain in terms of a plane wavefront. Okay, so for that I will consider a plane wavefront like this. This is a plane wavefront which is named as AB, and this is the direction of propagation. So the direction of propagation is like this. Okay, the direction of propagation of light is always perpendicular to the given wavefront, whether it is a spherical or it is a plane wavefront. So as usual I am going to locate 3 points, okay, like this. 3 points I have located. So one point is P, the other one is Q, and the third one is R. AB is a plane wavefront. On the plane wavefront, P, Q and R are the 3 points which I have considered. So according to Huygens principle, these points P, Q, R will behave like point sources. As a result, they will emit light, okay, in the form of small spheres. So these are point sources, so they are emitting the secondary wavelets. These small spheres emitted by P, Q and R, they are called as what? Secondary wavelets. Okay, I am going to join or I am going to draw a common tangent to all these secondary wavelets. So I get a new wavefront A dash B dash. The common tangent at these points you see here, the common tangent is an envelope of the smaller secondary wavelets. So A dash B dash is now called as a secondary wavefront. So the secondary wavefront or the new wavefront formed is always an envelope of the wavelets, secondary wavelets. Now can you see that the new wavefront A dash B dash is little away from AB? Because at a time t equal to 0, the given wavefront is AB. At a time t equal to t or t equal to tau, at some other time tau, where will be the position of the new wavefront can be located with the help of the Huygens principle. For that it is very simple. So with the given wavefront at a time t equal to 0, any point on the given wavefront as a center, okay, if you cut an arc whose radius is equal to the velocity of light into the time t, then that will give you the distance. Is it not? See here, velocity of light means what? Distance travelled by time. Therefore, the distance must be equal to what? Velocity into time. So, with the given any point on the given wavefront, say like P, Q, R, okay, with any point as a center, and you cut an arc of radius C into T, so that you can locate the position of the new wavefront. With respect to the old wavefront, where will be the new wavefront can be easily detected. So this is the use of Huygens principle. And there is only one drawback of Huygens principle is there. What does that means? We are considering only the forward envelope of the wavelets. Now there will be some back waves also. Okay, back waves. That will be ignored. Because when these secondary wavelets are progressing in the forward direction, their intensity will be higher. If you consider the secondary wavelets which are traveling in the backward direction, their intensity will be considered to be 0. So we always consider only the forward envelope of the secondary wavelets. So to summarize, my dear students, what is the Huygens principle means? You will have to write in 2 points. So according to Huygens principle, the first point says that every point on a given wavefront, behaves like a source of light and it emits secondary wavelets. Okay, it emits secondary wavelets. Now the second point is the forward envelope of all the secondary wavelets. The forward envelope of all the secondary wavelets gives a new wavefront, and the new wavefront is called as a secondary wavefront. Okay, students? And also we come to know that the direction of propagation of light will be always perpendicular to the wavefront, whether it is spherical wavefront or cylindrical or plane wavefront. In all the cases, the direction of propagation of light, you can see here also, you see this is a direction of propagation of light, A, B and A dash, B dash, both are plane wavefront. So at every point, you can see that the direction of propagation of light like this will be perpendicular to the wavefront. Okay, students, so this is very important. Okay, now using Huygens principle, can we locate the position of the new wavefront which is ahead of the given wavefront? Okay, so at a time t equal to 0, the given wavefront, okay, at time t equal to 0, the given wavefront is AB. Where will be the new wavefront A dash, B dash after a time t? After a time t, where it will be? It will be at a distance d equal to c into t. So, with any point on the given wavefront as a center, with any point, as a center on the given wavefront, you cut an arc of radius d equal to c into t. That will be the position of the new wavefront. Okay, students? Fine. See you.